Welcome to another video of my compositing tutorial series. This time we are going to properly remove the green screen from this video of a cat, stabilize the video, export it, and then add it into a 3D scene. Both the video of the cat and the 3D scene can be downloaded for free from my Ko-fi with the ability to leave an optional tip. And if you're interested in compositing with Blender, you might also want to check out my free pack MP-Comp, which includes over 100 node groups of unique effects for Blender's compositor. All videos of this series can be found in this playlist on my channel as soon as they come out, and each of them will include an individual and complete lesson from start to finish. Okay, we will start with removing the green screen from our footage. To start, we just have to create a new file, and I recommend to use the VFX preset for that, as we'll use a different collection of workspaces which will come in handy for us. Another tip I would like to give you is to open up the preferences of Blender, then go to System, and then at the very bottom under Video Sequencer we will increase the memory cache limit. This number determines the amount of RAM Blender is allowed to use to cache videos in megabyte. By default, this is set to 4 GB of RAM, which is a bit low in my opinion, but works if you only have 8 GB of RAM. If you have 16 GB of RAM, increase this to 8 or 12 GB, and if you have 32 GB RAM like me, I would recommend setting this to 16 GB. You can just multiply the default 4 GB by clicking into the value and then typing an asterisk followed by the number you want to multiply it with. After that, click here and save the preferences. So let's import our green screen footage by simply dragging it into the center area here. And as you can see, the video has been imported, but the colors are looking pretty desaturated. To fix that, we just have to go to the render properties and under color management, change the view transform from AGX to standard. This way our colors will display and export correctly. Next up, we're going to set the length of the video and the correct frame rate. You can see the frame rate right here in the footage settings. In this case, it's 30 FPS, so we're going into the output properties and set our scene to 30 FPS as well. Now to set the amount of frames of our scene so it is as long as the green screen video, we can just go over here to the movie clip editor and click on Set Scene Frames. And as you can see down here in the timeline, the amount of frames now matches the length of the video. And when moving through our timeline, you might notice this slight blue line at the bottom of the movie clip editor lighting up. This indicates which frames of our footage are cached, which increases the responsiveness of the preview. The frames will be cached dynamically when they are displayed, but you can also pre-process that by clicking this prefetch button here or by simply pressing P inside the movie clip editor. The size limit for this cache is defined by the setting in the preferences I showed earlier, and you can actually display the allocated RAM of Blender by right-clicking on the very bottom bar of Blender and then checking System Memory. Now, if I empty the cache by reloading the footage by pressing this button, you can actually see the decrease of allocated RAM. Now, if I prefetch it again, you should see the number increasing again. If we look at the beginning of our footage, you might notice that the camera is drifting a bit to the left. Same thing for the end of the clip. The camera is also slightly shaky, but since the cat is moving a lot, that isn't really that noticeable, so we can ignore that for the most part. But we should fix the drift at the start, because once we remove the green screen, it would look like the cat slides over the ground for no reason, which would look very awkward. So to fix this, we need to stabilize the video. All we need to do for that is to track the camera movement and then move the video into the exact opposite directions, so it kinda negates the movement of the camera in the clip. To track the footage, we first need to add a marker. We usually place this marker at areas in the footage of high contrast, because the marker will search its surrounding area in the next frames of the footage for these exact colors. So we get the location data of the marked area for each frame. And areas of higher contrast just makes it easier for our marker to not accidentally mistake another spot for the area we want to track. And we can actually let Blender automatically place markers on areas of high contrast by using the Detect Features button. As you can see, it automatically places markers on the cat as it has the most high contrast areas. This is a very cool feature, but since we want to track the camera movement, it would be a bad practice to use those markers because the cat is also moving, which would cause interference for our camera tracking. So we will have to track a static object in our scene, which in this case is the green screen. But of course, there aren't any high contrast areas in the green screen we could track. So we're facing a major problem right now. But depending on your display, you may or may not have noticed a few slightly bluish tints in the green screen. They are really hard to notice, but we can make them easier to see by expanding the clip display dropdown at the top and then deselecting both the R and the G channel, so only the blue channel of the video will be displayed. And now you can very clearly see that the green screen is a piece of cloth which has a few imperfections which we can perfectly use for tracking. I think especially this spot is very good as it is quite big and remains noticeable throughout the video. So we will add a marker there by first clicking the Add button here and then left clicking the spot. We can then fine tune it by using G to position it and S to scale it so the entire spot fits into the marker. Then we will tell Blender to use this marker to specifically look in the blue channel of the video for it by going into the track settings and then unchecking every channel except B. You can also see similar settings on the left here, but those only act as default settings for every new marker we would add. Usually you will want to add as many markers as possible, so that in case one marker accidentally loses track of its assigned spot, the other markers can be used to average that out. But in our case, we don't really have that many options, since the footage is rather noisy, which increases the risk of our markers to produce errors. So let's skip to this marker shot and track it. All we have to do is click this button here, so it will track for all the frames for Erode from our current frame. Then, if we weren't on the first frame and still have some untracked frames on the left, we are going to move back to our frame where we created our marker and then also track it into the other direction of frames by using this button. Now you should see these red and green lines in the timeline, which indicate changes of the position of our marker on the X and Y axes. So every time you see a spike in these graphs, there should be a lot of movement for our marker. And as you can see, we get a lot of them at one point because our fluffy little fellow enjoys the texture of the green screen, which is cute but destroys the purpose of our track. However, even though the footage is slightly shaky, you probably won't notice the shakiness in the end, as the cat is also moving a lot at the same time. So we can simply move to a frame before this little goofball destroys our track and cut it off by using this button. And about the slight drift at the end of our clip, we will also be able to get away with it, as for some reason the camera movement matches perfectly with the movement of our cat. So once we removed the green screen, it will just look like the cat walks out of frame, which we can also confirm by re-enabling the display of all channels for our clip and then re-watching that section. Now, to actually use this tracking data to stabilize our footage, we need to go to the Stabilization tab on the right, tick this checkbox, make sure our tracked marker is selected, and then hit plus to tell Blender this marker should be used for stabilizing. If we now skip through our footage again, you might be confused why you can't see any difference yet. This is because we have to apply the stabilization in the compositor and not the movie clip editor. So we switch to the compositing workspace up here, create a new node group, and then in the sidebar we make sure to set it to use our GPU for compositing and set the precision to full. Now, to get our video in the compositor, you might think you would just want to drag and drop it into Blender again. And usually that would be the correct way to import a video into the compositor. But since we already worked with the video using the movie clip editor in Blender, it's actually smarter to use a different approach. Because if we simply drag and drop a video or image into Blender's compositor, it will be imported using the image node. But the compositor also has a movie clip node, which if we add it, can simply be set to use our already imported video using this dropdown. This way, the compositor will reuse the cache from the movie clip editor. When using the image node, on the other hand, Blender will cache it twice using the image editor's caching. This happens because Blender will create a movie clip data block for a video when importing it in the movie clip editor and an image data block when importing it using the image editor. And by using the image and movie clip nodes, we pretty much get to use one of those data blocks in the compositor. And you can actually see a list of all the data blocks in your project by using the outliner. We just have to set it to Blender file, and then you can see that we have different categories, including an images and movie clips category. If we expand this, we can see the data blocks for our video. The advantage of the image data block when using an image node in the compositor is that you can easily control the start frame and the color space right in the compositor, and that its cache uses a bit less RAM in my experience. But the image node will only cache certain video and image codecs like ProRes. The movie clip node, on the other hand, will cache every video no matter in which codec and format it is in. And on top of that, the movie clip data blocks also include tracking data, which we will see when adding the node for stabilizing the video. So usually we want to import videos using the image node and make sure our video is in one of the cacheable codecs. But when doing tracking or masking using the movie clip editor, we use the movie clip node instead. So we connect the image output of our movie clip node and delete the nodes we don't need. And then we add the stabilize 2D node and insert it after our movie clip node. And then by using this dropdown, we select our movie clip data block, which will tell Blender to use the stabilization we set up in the movie clip editor before. So now we can already see the stabilization happening in the backdrop of the compositor, but to get a slightly better view of that, we add a new window to our workspace, set it to image editor, and then open the viewer node in it. If you don't see the viewer node, you might need to hit F12 once or reconnect the viewer node. So now we can see that the stabilization moves our video out of bounds, which cuts off the tail of our cat at the end of the clip. We can simply fix this by adding a translate node to move the video on the x-axis until the video doesn't look cut off anymore. Make sure to also zoom into the right edge inside the image editor, so you have an easier time seeing if the video really fills out the bounds now. Now, to actually remove the green screen, there are multiple methods of how to achieve this, and we are going to start with the quickest method. We simply add a keying node, insert it here, and then all we need to do is to select the color we want to remove. So we click on it and then use the eyedropper to sample the color of our green screen by simply clicking on it. And as you can see, we get a pretty good result already. Now, the special thing about the keying node is that it already integrates a lot of features to clean up our result, which you can access from the different dropdowns. For example, it will already add a despill effect, which removes the green tint our cat picks up from the light bouncing off the green screen. So you will usually start by adjusting the sliders in the key and tweak dropdowns. The balance will kind of control the intensity of the less prominent color channels regarding our key color. So in case of a green screen, we can control whether we want to compare it to the red or blue channel. Since the cat has more red than blue in its fur, we will want to set it to a value of 1. So the cat becomes more visible and some artifacts of the green screen will also be removed. Then with the black level, we can control the threshold at which semi-transparent pixels become fully transparent, and by using the white level, we can control the threshold at which semi-opaque pixels become fully opaque. So we can utilize this to make sure the cat is fully opaque and that some of the fur on the edge remains visible without accidentally picking up any artifacts. After that, you usually move to the post-process panel, where you can further customize the mask that is generated by the keying node to remove the green screen. By using the Dilate size, we can kinda increase or decrease the scale of our mask from its edges. The feather size will achieve something similar, but with a soft fall-off instead of hard edges. And since we still might pick up some artifacts of the green screen, we can use the mask panel to connect a garbage matte. A garbage matte is usually just a very rough mask you draw around the object you want to key manually, so we don't have to bother about artifacts appearing at the edges of our result. So I will set the keying node to show some artifacts on the edges to demonstrate the use case. Then we will create the garbage matte by going into the masking workspace at the top, select our video from the dropdown here, and then click here to create a new mask. Now to draw the mask, we have to hold Ctrl and then left click to create a new node for the mask. We simply repeat this, so we roughly draw a shape around our cat, and then to close the mask, we have to Ctrl left click on the first point again. Make sure to really hit the node, otherwise press Ctrl Z and try again. Now as you can see, some nodes here have a handle to adjust the shape of the mask, while some don't. This simply happened because I sometimes accidentally dragged my mouse a little while creating the point. But we can actually change the types of handles for the nodes by selecting the nodes we want to apply this change to, which in this case I will simply apply to all of them, and then hit V and select one of these handle types. For example, you could set them to auto, which will adjust the handles so they always create smooth lines. But as you can see, adjusting the handles of it will also move the opposing handle as well. If you want to move both handles individually, you can select them all and hit V again and then set it to free instead. This way we get full control over the handles. So the most important part for our garbage matte is that it will always cover the entire cat. So make sure to skim through the video and see whether the cat stays inside the mask and adjust the mask accordingly if you have to. Since the cat walks out of the screen at the end of the video, we will have to animate the mask to follow it there. So we just move to a frame where the cat is about to start moving, hit I to insert a keyframe, move a few frames forward, and then move the mask by using G, so the cat stays contained in the mask. Then we just hit I again to add another keyframe. And as you can see, the mask will now follow the cat there. Now we switch back to the compositor and add a mask node. From there, we can simply use the dropdown to select the mask we have just created and then connect it to the garbage matte input of our keying node. Then we just add an invert node and place it after the mask to invert it, and we have our garbage matte applied. Now, since we stabilized our footage, make sure to put the stabilize 2D node after the keying node, because otherwise our video will be stabilized and moved while our mask stays in place. Now I will show you the more manual way to remove a green screen, so you have more control to refine your keying setup. And we will start by adding a color key node, which we will insert here, and then we're going to click into the color again and use the eyedropper to sample the color from the green screen. Now by using these sliders, we can control the tolerance at which colors are being recognized as part of the green screen. So we essentially control how much difference there can be in the hue, saturation and value of the green screen. Since our cat's fur is in a slightly yellowish hue, which is pretty close to green, we will want to keep the hue tolerance as low as possible. Regarding the saturation and value, we can use higher values. Just pay some attention on the white fur and the fur that received a slight green tint from the green screen. But since there is a lot of unevenness in our green screen, we can make use of another node of the compositor, which will create a gradient from multiple points of the green screen. To do so, we first have to specify those points, so we switch back to the motion tracking workspace. We essentially just have to add a few markers, but since we already have a tracked marker for our stabilization, we will add those markers on a different layer. So we expand the Objects panel on the right and click on the plus icon to add another object, which effectively works as another layer for our markers, which is why our previously created marker disappeared. Now we just add a few markers to sample different shades from the green screen, so make sure to place them on points where the color looks very different. Then after you place them, make sure the cat is never touching any of the markers and adjust the markers if necessary. And that's pretty much all we have to do. We could also track the markers, but we don't have to, as they will simply be used to sample the colors from the spot they're on. Now we switch back to the compositor and we add a keying screen node. From the dropdown, we select our video again, and then we select the object or layer we place the markers on. After that, just connect it to the key color and then make sure to place the Stabilize 2D node after the color key so everything aligns nicely. And this gives us a slightly cleaner result and makes it a bit easier to adjust our color key node. Now to remove the green tint from the cat, we will add a color spill node. It is already set up to expect a green screen by default, but to get a slightly better result, we set it from single to average. So it already looks quite good, but if you zoom in a bit, you can see we have some coarse pixels which are kinda separated from the cat. Now to fix this, we have to edit the mask our color key created a bit. As you can see, the color key node has both an image and a matte output, which if we preview it, we can see will simply output the mask it creates instead of already applying it on the image. So we will create a setup to manually apply the mask in order for us to further customize it. To do so, we will have to add a set alpha node. Now we will have to connect our source footage into the image input of it, so we add a reroute here by holding Shift and right click and then dragging a line through the connection here. Then we will drag another connection from this reroute to our set alpha node and then connect the matte output from the color key node into the alpha input. Now to actually remove those coarse pixels, we will add a Despeckle node and insert it right after the matte output. This node will try to detect noisy areas in our image and then average them out while leaving the rest of the image untouched. All we have to do is to play around with both threshold sliders until we don't see any coarse pixels anymore, while still keeping as many details as possible. Now we can further edit our mask by using a Dilate/Erode node. So we will just add it and insert it here. And this node basically applies the effects we already saw in the post-process tab of the keying node earlier. So we can use this to increase or decrease the scale of the mask. Since the cat has a lot of fine hairs, we will set the node to feather, so we can get a soft fall off that will gently pick up some of the hairs on the edges. So we will just increase the size of the effect slightly until we get as many fine hairs as possible without picking up too much of the green screen again. Because of the color spill node, the green screen received a blue tint instead, so anything blue here is just the green screen. And since hairs are very fine details, I found that setting the fall off of the feathering effect from smooth to sharp, which will apply the fall off more punctual as the fall off will end sooner, looks better. As you might have noticed, we sometimes still get a slightly blue tint on the edges of our cat. To make this less noticeable, we can try targeting those blues and changing the color of them to better blend in with the rest of our cat. To do so, we will add a Hue Correct node, which we will insert after the color spill node. Now, using this node, we can change the hue, saturation and value of individual hues on the image. So we click on the H here, so we change the hues, and then we move those points that align with the blue hues on the spectrum further down until they become orange and fit the hue of the cat's fur. Then we can click on the S here to adjust the saturation of those blue colors. So we just slightly decrease the saturation for the blues, so they look more like they are part of the cat's fur. Now, to also apply our garbage matte on here, all we have to do is to add another set alpha node after our Hue Correct, use a mask node to import the garbage matte we've created, and then connect it into the alpha input. So this is the finished setup. You can further spend time adjusting all of those parameters to refine your result, just don't spend too much time on it. Now, to render and export our result, I will switch to the rendering workspace up here. I recommend rendering it as a PNG sequence, as it will make it easier to further process it using Blender. So I will just specify a folder that I want the PNGs to end up in. Then, to increase the render speed a bit, I recommend going into the render properties and then setting the render samples to 1. After that, just press Ctrl and F12 to start the render and wait until it finishes. So now I will quickly show you how you can add a 2D video into a 3D scene. To showcase this, I've created a small scene which you can also download if you want to. To add the PNG sequence we just rendered, we simply have to press Shift A, go to Images and then select Mesh Plane. Then we will have to navigate into the folder of our PNG sequence and make sure that Detect Image Sequences is checked, so it will import it like it's a video and not create an individual mesh plane for each image. So just select all images by pressing A and then confirm. And this should give us a plane that uses our PNG sequence as a texture, which we can just position in the scene like it is a 3D object. So I will just try to position it in a way that it looks like the cat walks behind the barrel at the end. Then I will set the project frame rate to 30 FPS so it matches the footage, and adjust the amount of frames. And another pretty important technique I want to show you is how to apply compositing effects specifically to the cat. I will use the real-time compositor for this, so I'm going to open a new window and set it to the compositor, enable the real-time compositor for the camera view, and then set the compositor to GPU and full precision. Then what we'll have to do is go into the view layer settings right here, where we can enable different render passes. And what we want to enable here is the Cryptomatte pass for objects, so we will tick this checkbox here. Now back to the compositor, we are going to add a Cryptomatte node and then preview the pic output of it. This gives us a preview where we have an easier time to see the different objects of our Cryptomatte pass, So we're going to tell the Cryptomatte node to create a mask for our cat by clicking this plus icon, which will turn our cursor into this eyedropper, which we can use to select an object from our preview. So simply left click on the mesh plane of the cat. And now the Cryptomatte will automatically create a mask for that object. So we could add a color balance node, connect our original image input to it, and then connect the matte output to the vector of it. And now if we play around with the settings of it, we can see that the node will only be applied to our cat. But not every node has a vector input. So if you would want to use a blur node and exclusively apply it to our cat, we would need a mixed color node. Then we simply connect the original image and the result of the blur node to it, and then connect the matte to the vector of it. And this way the blur will only be applied to the cat. Just make sure to not overdo it, as the blurred image can't leave the boundaries of the mask from our Cryptomatte. So high blur values would give us this weird looking result. One more thing. Since the mesh plane is basically using a principled BSDF shader that uses the color and alpha channel of the PNG sequence to display the cat, it will cast and receive shadows. But since our light is coming directly from the top and the mesh plane is flat, the shadow looks off. So we will create a better looking shadow by using shader nodes. First, we disable the shadow our cat is casting by selecting it, going into its object properties, and then we expand the visibility panel and uncheck shadow. Since we want the shadow to be casted onto the ground, we will have to edit the shader of the ground. For this, we will use an ambient occlusion node, which will create a black and white gradient everywhere other objects are touching the ground. Then, to actually get the shadow, we will just add a transparent BSDF node and use a mix shader node to combine it with the principled BSDF. Put the transparent BSDF into the top shader input, the principled BSDF into the bottom input, and then connect the AO output to the vector of it and to the color input of the transparent BSDF. Then by using the samples value, we can set how many iterations our ambient occlusion node uses to generate the shadows. So a higher sample count will make the shadows look smoother and more accurate, but will also use more performance. By using the distance value, you can control the maximum length of the shadows. You can also add a color ramp node to further edit the intensity and fall off of the shadows. Another thing we can change is how our cat responds to light, because currently, depending on the frame, it can look a lot like the cat is just on a poster or sticker. But we can make the light look less flat on it by selecting it and then edit its shader in the shade editor. So we will add a bump node and connect our PNG sequence to its height input. Next, we connect the normal output of it to the normal input of the principled BSDF. So by using this bump node, we will basically generate a bump map based on the images of the cat. So the light is reacting differently to different details of the cat. We just have to slightly increase the distance of the bump node and also adjust the filter width until we get the level of detail we want. After that, bring down the strength of the bump node as we want the effect to be quite gentle. When you finish that, you can just play around with different roughness levels on the principled BSDF to control how much the light on the cat is being spread. So yeah, this was everything I wanted to show you for this video. I hope you found it helpful. Kinda tried a different pacing than in the last tutorial, so I hope you liked that. I've also made a composited animation by using different MP-Comp nodes, which you can also just download for free from Ko-fi and use for learning. See you in the next tutorial or whatever video will be next. Bye!